Hello, students. I'm going to take a moment to go over some of the other theorems. Again, these are things that could absolutely be included on an exam. And that would be specifically related to perpendicular bisectors and angle bisectors. So what I want to do is take some time to prove theorem 12.8. I'm going to go both directions. And I'll do the same for the perpendicular bisector piece that was earlier in 12.1. Okay. So what's the big idea with these? So let's see. Actually, I won't be doing any constructions. These don't require any construction style proofs. So I'm not going to construct anything because that isn't critical. So let me see if I can just share my screen and we'll do a whiteboard share. And oh, we're loading the whiteboard. Okay. Explore new tools. I really wish they didn't have new tools. Share a board, comment all on Zoom whiteboard. Fantastic. Infinite possibilities. Endless creation on one page, both in and out of meetings. Oh, that's fantastic. Okay. Let's go ahead and start. So I'm going to grab a pen and we'll start with red. So what's the idea? Let's start with the perpendicular bisector one. Okay. So there are two parts to it. First is to say if you have 2 points A, B, okay, so we kind of create them here. And then this line, which is perfectly straight, is the perpendicular bisector. So L is perpendicular bisector of AB, okay? And we need to prove any point on L is the same distance from A and B. Okay, that's what we're trying to show. All right, so here's what we're going to do. What do we need to do? We need to prove this statement, any point. So pick a new point. Okay, we'll call it P. And if you want, go ahead and construct these other sides so that we're gonna obviously use some triangle pieces here. And I'm also going to label this point down here as M. Now here's the key piece. L is the perpendicular bisector of AB. So that means because it's the perpendicular bisector of AB, that means a few things. One, it means that AM has to be congruent to MB. So I'm going to mark that with a little tick mark. Okay. It also means because it's perpendicular, it means that angle AMP is congruent to angle BMP, and both are 90 degrees. Okay, so mark that. Okay. And now here comes the fun. So these are all from the definition. What does it mean to be a perpendicular bisector? Right? Since L is perpendicular bisector. Okay. Now, all we need is one more side and we have congruent triangles. And take a look. The side down the middle, PM is congruent to PM by the reflexive property. And that's all we need. Now we have triangle AMP is congruent to triangle BMP by side angle side. What does that mean? It means corresponding pieces like AP has to be congruent to BP by CP CTC. So P is the same distance from A and B. And that is what we wanted to prove. Now notice P, we picked any point. We picked any point. We just called it P. We could have picked any point, but it doesn't matter which point you pick, as long as it's a point on line L and as long as it's not the midpoint itself, because we need to make a triangle. This exact argument will work just fine. All right. Whew. Okay. So now let's go the other direction. Page 1. Add a page, please. Okay. So now here we go. We're going to go the other direction. What would that look like? Okay. Well, it would say, once again, I have the segment AB. Okay. And this time I have a point P, and I know that it's the same distance from A and B. P is the same distance from A and B. Now our goal is to prove that P is on the perpendicular bisector of AB. That's what we want to show. Okay, so let's start. That's what we're trying to prove. So let's see here. We can find the midpoint of AB, and we'll call it M. Okay, so wherever that is, call that M, and that means this length is the same as that length. So AM is congruent to MB. Okay, perfect. Now connect M to P. And I will just draw that in right there. So MP is congruent to MP by the reflexive property. Okay. And look, I've got perfectly congruent triangles. I've got triangle AMP is congruent to triangle BMP, this time by side, side, side. Okay, I don't have an angle this time, but I do get that angle AMP must be congruent to angle BMP by CPCTC. The corresponding parts of a congruent triangle are congruent. Let's mark that. So that means this angle, these two angles are the same. I don't know how big the measurement is, so I'll just call it X. And they are supplementary. So X plus X has to equal 180 degrees, which means that 2X has to equal 180 degrees, which means X has to be 90 degrees. What does that tell us? If it's 90 degrees, it means that MP has to be perpendicular to AB. And look where it intersects. M is the midpoint of AB. So what do we know? P is on the perpendicular bisector of AB. Perfect. We're going to do something similar with angle bisectors now. So what do we have? First we have to create an angle. Okay, so here's an angle. And I have no idea. We'll call it CAB. Okay. So we have angle CAB. And let's see here. First off will be, let's say if it's on the angle bisector, then it has to be the same distance from the sides. And if it's the same distance from the sides, then it must be on the angle bisector. So pick a point out here in the middle. We'll call that P. Pick P in the interior. So I'll only label that point P. So when we find this distance, the distances are the same. So P is same distance from AC and AB. Okay. And let's see here. Next up, we'll draw AP. Perfect. All right. So AP is congruent to itself. Boom, boom. And now this is where we would normally have a dilemma. We'd have a dilemma because we have angle side side. But the angle in this case is considered a right angle because it's the same distance. So I'm going to label these points as point D up here and point E down here. And there is a property that says the issue we had with angle side side comes up when we could have multiple triangles. That is not the case if you have a right triangle. So what we know is that triangle APE is congruent to triangle APD by a special case of ASS known as hypotenuse leg, which in a right triangle means if you know the hypotenuse and you know one of the other sides, you get congruent triangles every time because it's a right triangle, right? So now I have congruent triangles, and that means that angle PAE is congruent to, angle PAE is congruent to angle PAD by CPCTC. Okay. And, and if you wanted to see where is hypotenuse leg, that's from section 12.1. Figured somebody would probably say, where'd that come from? That's in section 12.1. And that means that because these angles are congruent right here, that means that PA is the angle bisector of angle A. So if you pick a point that's the same distance from the sides, it has to be on the angle bisector. Right? Let's go and try the last piece. What happens with the last piece? The last piece is, once again, we have an angle, CAB. So we have an angle, and we're going to draw the angle bisector. Draw angle bisector of angle CAB. Okay, it is the angle bisector, which means by definition, the angles there must be congruent. Now, pick any point. Pick a point on the angle bisector. Okay, we'll call that point P. And create the distances to the sides. Okay, so create that distance to the sides. Now what I really have here is I know that AP is congruent to AP by reflexive. That's the segment going down the middle. And I need to label these points once again, because it doesn't have to be at points B and C. So now I know angle ADP is congruent to angle AEP because both are 90 degrees. And angle DAP is congruent to angle EAP because it's the angle bisector. And now you have two congruent triangles. So in triangle APD, I guess is what I'm doing. APD is congruent to triangle APE by angle side. And if we have congruent triangles, then DP is congruent to PE by CPCTC. What does that mean? If you pick a point on the angle bisector, it has to be the same distance from the sides of the angle. So these are kind of they're forwards and backwards. None of them are really all that bad, but they do require you to be a little bit familiar with these ideas. I wanted to create this as a way to show you all the steps that you may use as you go through and prove these. So again, 4 proofs. No, I don't typically make this test all proofs. That's not the goal. But there will be a couple things you will have to prove on the test. At least one with constructions where you use your compass and straight edge. And at least one where you don't need to do constructions, where you have something already drawn for you, but you still have to go through the proof. All of these proofs require similar triangles. Congruent triangles. So side, angle, side, 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 angle, side, angle, side, angle, side, like I just did there. So make sure you understand those pieces completely, and you should be on your way. All right, off you go.